Defining a power. A power is made up of a base and an exponent and is an efficient way to show repeated multiplication. For example, if we have 8 times 8 times 8 times 8 times 8 times 8, we get 8 as a base with an exponent of 6. And this is sometimes read as 8 to the 6th power. So although technically 8 to the power of 6, the power is really the entire thing. So that whole thing is a power. Often we interchange exponent and power a little bit, but the technical part, the 6 is the exponent and the 8 is the base, and the entire number 8 with that exponent 6, that entire thing is known as a power. Okay, so another example, if I have negative 2 to the power of 5, what do I get? Well, if you think about this as negative 2 times negative 2 times negative 2 times negative 2 times negative 2, then I multiply and I get 4, 8, 16, 32, and look at the signs. Two negatives make a positive, and another negative is a negative, and another negative is back to positive, and another negative is a negative, and I get negative 32. Well, if we continue this pattern a little, and we look at a few more examples, let's see what happens. Okay, so now that we've seen a little bit of this pattern, I have a question for you to think about and bring your answer to class. And that is this. You see a pattern with the sign of the answer, so positive or negative, and the value of the exponent. Okay, here's another example, and this one is a little bit tricky, so I'll walk through it for you. Negative 2 to the power of 5. Notice no brackets. Well, what this means is very important to how we go about calculating it. That negative sign in front of the 2 to the 5th really means negative 1. We don't write the 1. Times 2 to the exponent 5. So you think about that as negative 1 times 2 times 2 times 2 times 2 times 2. So this part is 32, and then it becomes negative 32. These ones are a little bit tricky, and people often make mistakes with them. One thing that you can think about it is, well, if it was 2 to the 5th, then it would be 32, and I'm taking away 2 to the 5th, so negative 32. It's just another way to think about those ones. If the brackets are in a different spot, as we saw with previous examples, it does make a big difference. But if the negative's just in front, it makes the entire answer negative, or opposite to whatever it was before. Okay, let's take a look at another pattern and another question here. So my question is, what's this one worth? 2 to the power of 0. Well, again, it's a little hard to know without using a calculator and just guessing. So let's take a look at some patterns. And this is a favorite strategy of mathematicians. So if I have 4 to the power of 3 all the way down to 4 to the power of 0, it would look like this. And similar 3 to the power of, and I'll do 10 to the power of as well. And then let's fill these in. 4 to the power of 3. 4 times 4 is 16. 16 times 4 is 64. This means 4 to the power of 1. And we'll go 3 times, 3. 3 squared is 9. 9 times 3 is 27. 10. 10 squared is 100. 10 cubed is 1,000. And now let's look for this pattern. What do I have to do to go in this order? For instance, how do I go multiply or divide from 64 to 16 and then 16 to 4? And the answer to that is you divide by 4 each step. And if I divide 4 by 4, I end up with an answer of 1. And let's see what happens in this pattern. 27, if I divide this by 3, I get 9. If I divide by 3 again, I get 3. And if I divide by 3 again, I get 1. And over here, if I divide by that base of 10, I end up with 1,000 to 100, 100 to 10, and 10 to 1. And so by looking at this pattern, it looks to me like there is a pattern with the answers when the exponent is 0. And that is true. Anytime that the exponent is 0, we get an answer of 1. At least that's what the pattern looks like.